example 3, we're going to find the vertex, the equation, and the y-intercept, but this time we're going to use an equation, not a graph. So this is a little trickier, but remembering that our axis of symmetry is always x equals minus b over 2a makes this a lot easier, because right here is my b value, there's my a value, just like we learned before with quadratic functions. It goes a, b, c. So I do minus b, negative 4, all over 2 times a, which is 2. I get negative 4 over 4, which is just negative 1. So now I know my axis of symmetry, and a lot of times I just abbreviate symmetry to SYM, x equals negative 1. If I know what my axis of symmetry is, I automatically know what the x value of my vertex is going to be. It's going to be negative 1. And now I just have to find out what the y value is for my vertex, and I'm going to do that by saying y equals, and I'm going to plug negative 1 in for x. Since I know the x value is negative 1, I'm just going to plug it into the equation to see what y is when x is negative 1. So I get y equals 2 times negative 1 squared is 1. 4 times negative 1 gives me minus 4 minus 3. 2 times 1 is 2. 2 minus 4 is negative 2. And negative 2 minus 3 gives me negative 5. So the vertex is negative 1, negative 5. And then to find the y-intercept, this is the easiest thing we can do, because we know the y-intercept is just going to be whatever c is. C is negative 3, so we know the y-intercept is 0, negative 3. The reason that works is because if you think about it, if I would plug in 0 for x, when I plug in 0, 0 times anything is 0, 0 times anything is 0, and I'm just left with y equals negative 3. That's why the value of c is always going to be your y-intercept, because plugging in 0 for x makes all the terms with x's go away. And there we've done it. We've just found our axis of symmetry, our vertex, and our y-intercept. Once you find the axis of symmetry, that gives you the x value for your vertex, and you can use that to find your y value for your vertex, and then your y-intercept is the easy part.